this is example number 4, and I wanted to spend a little time with this one. So you can see on the left, the right-hand side looks pretty simple, cosine theta minus sine theta, but the left side is really got a lot of negative signs in it. But because of our even-odd identities, we can clean that up a little bit. But I want to go through it to show you how to do this. It can be a little tricky to write out sometimes, and I'll want you to understand it. Okay, so I'm going to take that numerator and write sine negative theta squared. Now, I haven't used an identity or anything. I'm just writing it in a different format so that you can see the sine negative theta and that that is what's being squared. That's going to be important with what we're going to do here in the numerator. I'm going to do the same thing over on the other term. So I'm going to write cosine negative theta squared. It would be easy to get confused on this problem. Okay. In the denominator, the functions aren't being squared. And so I can just use the even odd identities. So my sine negative theta will be negative sine theta. And then it'll be minus cosine theta. Cosine negative theta is just cosine theta. Okay, so in the numerator, I'm going to simplify what's in the brackets, the square brackets. So I'm going to have negative sine theta squared minus cosine theta squared over, in the denominator, I'm going to factor out a -1. Now, how do we know to do that? Well, it looks a little suspicious to have negative sine theta minus cosine theta, so this looks a little bit better. Okay. Later we'll see how that's going to work. Now, when I square the first square brackets, you know, the negative sine theta, that's going to become positive because I'm squaring it, and so it's going to be sine squared theta. It's not negative, it's positive because you're squaring that negative sine theta. Okay, the minus sign is still there. Cosine theta squared, we're going to write it in the other form, cosine squared theta. That's how we normally see it. Okay, over -1 times sine theta plus cosine theta. And hopefully I don't write too big. Now remember that we can use the algebra that we have even though we have trig functions involved. So in the numerator you have something squared minus something squared. That's the difference of squares. And so we're going to factor the numerator into sine theta plus cosine theta and sine theta minus cosine theta. The denominator hasn't changed for a while. Okay, now I can cancel sine theta plus cosine theta with sine theta plus cosine theta. And I get -1 times sine theta minus cosine theta. Now I'm kind of out of room, so I'm going to do kind of a no-no here and go over to the side. When you have a negative and you have an expression inside that's two terms and it's subtraction, that negative in front is just going to switch those around. You can distribute it and rewrite it, but you should learn that that's going to equal cosine theta minus sine theta, and that's what we wanted. So that now we're done. But that's another little tip there to try to remember. Okay. So I'm going to go ahead and do example 5, and then I'll do the other 2 examples on another video. Okay, so we have a 1 on the right-hand side. That's pretty simple. And then we have 1 minus cosine squared x and 1 plus cotangent squared x. 1 minus cosine squared x, that's one of those identities we talked about before. It's going to be sine squared x. So it's one of the Pythagoreans. And then 1 plus cotangent squared x, that is also a Pythagorean, which is going to be cosecant squared x. So you can look those up. Then my multiplication sign's a little low there. Okay, now I have sine squared x. I'm going to use the reciprocal identity, 1 over sine squared x, and then those are going to cancel, and we just get 1. So that's what we wanted. Okay.